Okay, so let's have a go at doing these questions. So hopefully you've read the revision bit at the beginning. There's 8 questions, so I'm going to try and help you through them. If you could try them first, and then we check your answers in the video afterwards. So question 1, pause the video and have a go at that one yourself. Okay, so it says we've got a curve C, we've got the equation, we've got 0.46 lies on the curve, and L is normal to C at point P. We've got a region which is bounded by the line L, which was the normal, the line with equation x equals 2, as you can see, and the x-axis. Show that the area of R is 46. Okay, so work through this bit by bit. What we need, first of all, is we need to work out the equation of the norm. So for this one, to get the equation of the normal, we first of all need the gradient. So we do dy by dx, but before we do that, we need to write y in the form ready to integrate. So 32x to the minus 2 plus 3x minus 8. Differentiate it, we get minus 64x minus 3 plus 3. We sub in x equals 4, because that's the coordinate of p. So we get dy by dx equals minus 64 times 4 to the power minus 3 plus 3. We get that's 2. So therefore, m equals minus a half, because it's the normal, so it's negative reciprocal. So we can get the equation now by doing y minus y1. So y minus 6 equals minus a half x minus x1, which was 4. I'm going to times by 2 and expand by minus 1. Take everything to one side, so x plus 2y minus 12 minus 4 is minus 16. So that's the equation of the normal. Now, to get the area, well, we can split it up into this area and the triangle. So to get the area of the triangle, we know that the x-coordinate of the triangle is 4, because that's p, that was 4, 6. We know the height here is 6. So to get this length, we need this x-coordinate here. And the x-coordinate happens when y equals 0. So in the equation of our normal, I'm going to sub in y is 0. I'm going to get x minus 16 equals 0. So therefore x equals 16. So I've got this distance here from 4 to 16 is 12. So I know the area of the triangle is half times 6 times 12, which gives us 36. Now to get the area of this little curved bit, well, that's the integral, that's the area underneath C. So to get this here, we're going to integrate y between, well, goes lock on the question 2 to 4. So we're going to integrate y between 2 and 4 with respect to x. So we get 2 to 4, 32x minus 2 plus 3x minus 8 dx. Now I'm just going to show the working out for this. So add 1 to the power, divide by it. So minus 32 minus 1, add 1 to the power, divide by it. And add 1 to the power, divide by it. So that's what we get when we integrate between 2 and 4. Sub in the first limit first. So minus 32 times 4 to the minus 1 plus 3 over 2, 4 squared, take away 8 times 4, and then take away the bottom one. So sub in 2. Now I'm going to work each of these out one bit at a time. Minus 32 times 4 to the power minus 1 is 1.5 times 4 squared. Take away 4 times 8. So that gives me minus 16. Minus, change up the 4's to a 2. I get minus 26. So minus 16 minus minus 26 gives us 10. So the total area is this bit here, which was 10 plus the triangle, which is 36. 10 out of 36 is 46. That's what the question wanted us to do. I'm just going to pause it so I can take a picture of this. Okay, next one, question 2. It's very similar, and I think this has also been one of your assessments this year. So again, have a try this one yourself and unpause when you're ready. So we've got a curve, and it says the curve has a minimum turning point at x equals k. The region R is bounded by the curve, the x-axis, and a line x equals k. So a line at the minimum point. Show that the area R is 256 over 3. Well, we're given a minimum turning point. So this is why I keep putting those knowledge tests to test that I know what they mean. So minimum means dy by dx equals 0, and d2y by dx squared is bigger than 0. Well, if we do dy by dx first of all, so we got y in the question. So y was 2x cubed minus 17x squared plus 40x. So if we do dy by dx, we get 6x squared minus 34x plus 40. And if we make that equal to 0, then we get 6x squared minus 34x plus 40 equals 0. We're allowed to use a calculator to solve that. So it was 6 minus 34 and 40. So we get x equals 4, or x equals 5/3. Now, you could use this to work out which one of these it is. But if you look at the diagram, you can see that this maximum point first. So the maximum point must be this one. And then secondly, we have a minimum point. So x equals 4 must be the minimum point. Okay, so I've got the coordinate for the minimum point, the x coordinate. I haven't got the y one. I'm not going to work it out until I'm told if I need it. And now to get the area, well, the area under the curve means integrate, and we're going to integrate from 0, the origin, to x equals k, which is 4. So we're going to integrate from 0 to 4, y. So if we integrate y, we get 2 over 4, which gives me a half, x4. Take away 17 over 3, x cubed. 40 over 2 gives me 20, x squared. Yeah, if you need to write that step out before and then simplify it, do that. Since to show that, let's show the working. So sub in the 4 first. And then sub in 0. So it just gives us 0 because everything's look, that's 0, that's 0, that's 0. So when I sub in 4, let's see what we get. 17 over 3 times 4 cubed plus 20 times 4 squared. There we go, 256 over 3, which is the answer. So again, I'm going to pause it so that I can take a photo. Okay, question 3. We've got a curve C has equation y equals f of x, and the point 35 lies in C, and we've given the equation for f dash of x and the derivative of x, and we want to find f of x. Well, remember, to get from the derivative back to the original, we integrate. So we're going to integrate 3x squared, take away 8x plus 6, and we get, add 1 to the power, divide by power, so 3 divided by 3 is 1, so x cubed, add 1 to the power is 2, divide by 2 is 4, plus 6x plus a c, so that gives me what f of x is, or y. And now there's a plus c, so to get it, we're going to sub in what we know. So when x is 3, y is 5. That's what y was. So we get 5 equals 3 cubed, take away 4 times 3 squared, plus 6 times 3 plus c. The 5 equals, simplify this side, so 3 cubed, take away 4 times 9 plus 18. Get 9 plus c, so c is minus 4. So we've got f of x is x cubed, take away 4x squared plus 6x minus 4. That's part A done. Part B says verify that the point 2, 0 lies on C. So x is 2, y is 0. So to verify it, I'm just going to sub in. When x is 2, we get f of 2 equals 2 cubed minus 4 times 2 squared. 6 times 2, take away 4. I'm going to work that out. And we're hoping to get 0. And we did. So therefore, 2, 0 lies on C. Since it's a verified question, I would have a little sentence at the end to make sure I get the mark. And then finally, it says the point Q also lies on C, and a tangent to Q at to C at Q is parallel to tangent to C at P. So that means they have the same gradient. So my curve could look something like this. This tangent here, it could be parallel to, let's see if I can draw it properly, maybe it's this tangent here. So the gradients are the same. So the first thing I need to work out is what's the gradient at Q. So to get the gradient, I'm going to use dy by dx, or f dash of x, and I'm going to sub in the point of Q, which is 3. So I'm going to do f dash of 3, so that's 3 times 3 squared, take away 8 times 3 plus 6, so that gives me 3 times 9, take away 24 plus 6, gives me 9. So I know the gradient should be 9. So therefore, I know the gradient, so f dash x should equal 9. So I've now got an equation to solve. 3x squared equal 8x plus 6. That's the gradient function, that's f dash of x. And I want that to equal 9. So I'm going to take the 9 to that side. And I'm going to solve that quadratic on my calculator. And hopefully, one of the answers should be 3, because we know the 0.35 has the same gradient as what we're looking for. So we get 3 minus 8 minus 3. My two roots are x equals 3, like we wanted, and x equals minus a third. So that's the point P. So this must be the point Q. And the question just wanted the x coordinate. So that's all they wanted, x equals minus a third. Yeah, so we worked out the gradient at P. We made the gradient equal that gradient, the derivative equal that gradient. Then we solved it to get the other coordinate, which must be Q. So x equals minus a third. Again, I'm going to pause it. Okay, question 4. So again, have a try of this one yourself. So we've got that area there, and it says, show us a sketch y equals root x. The region R is bounded by x equals 1, the x-axis, and x equals a. So we don't know what a is, just that it's a constant. And we're given that the area is 10. Okay, so they give us the area, so at some point, I imagine we're going to have to work out a. So finding its simplest form, the area between 1 and a of root 8x. Well, root 8x I can split up into root 8 times root x. And numbers I can take outside the integral. So I can factorize out the root 8, which is 2 root 2 anyway, so it's right like that. 1 root x dx. But we know that the area between 1 and a of root x is 10. So that's just 2 root 2 times 10, which is 20 root 2. Yes, we know from the picture this. So I'm always trying to use that. Okay, II. Once area between 0 and a of root x dx. Well, this time I'm going to split the area up from 0 to a. First of all, we're going to do 0 to 1, and then 1 to a. because I know 1 to A, I know this bit here is 10. They told me that in the question. And this bit I can work out. That's just, well, if I do this at the side, so root x dx, well, that's x to the power of a half. So add 1 to the power gives me 3 over 2. Divide by the power gives me 2/3. X to the 3 over 2. 0 and 1. Sub in the first one first. So sub in 1, I just get 2/3. Take away sub in 0, I just get 0. So it's just 2/3. So it's 2/3 and 10, which gives me 10 and 2/3 as a mixed number. Although if you hate mixed numbers like me, then you can write it as 32 over 3. Okay, it's not too tricky. Just spotting that. I wish I could point on the screen. Just spotting that little white area there and the grey area makes the area I want. So the white area is this bit between 0 and 1, plus the grey area, which the question tells us is 10. And finally, part B is asking us to find A, where it says show that A can be written as 2 to the power of k, where k is a rational constant. Rational just means a fraction, so that means A is going to be 2 to the power of something. So it could be square root, for example, or something like that. So let's have a play around. So what we do know, we know this, and we know that root x is x to the half. So I can integrate that like I did before. So I get 2/3 x to the 3 over 2. Between 1 and A, it's 10. Sub in A first, so 2/3 A to the 3 over 2. Sub in the 1 next, which just gives me 2/3, and that equals 10. Well, I'm going to times both sides of the equation by 3 to get rid of these fractions. So I get 2A to 3 over 2, take away 2 equals 30. I'm going to add the 2 to that side, so 2A 3 over 2 equals 32. I'm going to divide by 2, so A to 3 over 2 gives me 16. Then to get rid of the power, I do the reciprocal on this side, so A to the power 16 to the power 2/3, sorry. And here's the trick of once you've written as 2 to the power, so I can write 16 as 2 to the power of 4 to the power of 2/3. Power and power, I times it, so I get A to the power of 2, 8 over 3. Now that's a fraction, so it's a rational number, so k must be 8 over 3. So that one was tricky, but again, it's just make an equation, use what you know, make an equation, and solve it. Okay, question 5 now. Again, hopefully you've had a go at it. So we've got part of a sketch for y equals, let's write down 4x cubed plus 9x squared, take away 30x, take away 8, between those points. And it says the curve has a turning point at A. Using calculus, show that the x coordinate of A equals 1. Okay, well, remember, turning point means it's stationary, so that means dy by dx equals 0. So what we're going to do is we're going to differentiate it. So 12x squared plus 18x take away 30. And we're going to make that equal 0 and then solve it. We can use a calculator. So 12, 18 minus 30, and we get x equals 1 or minus 5 over 2. Now, if you look there, you can see that A is between, well, A is positive, first of all. A definitely has to be 1. Yeah, because A has x bigger than 0, so it has to be that one. Okay, and part B, it says the curve crosses the x-axis at 2, 0 and minus a quarter 0. So we've got the coordinates of where it crosses B and C. Now it says the finite region R is bounded by the curve, the line A to B, and the x-axis. Use integration to find the area of the finite region R and give answers to 2 decimal places. Well, we're going to be sneaky. We're going to split that area up into this area here between C and A, and then we're going to split up into a triangle between A and B. Yeah, because I've got a white area there. I can't work that out easily. So instead of trying to work that out and take it away from the curve, I'm going to split the shape up so I can see a nice triangle. Okay, so let's write down what we know. So this point A, we know the x-coordinate was 1. So this was 1. We know that B was, it tells us in the question, 2, 0. So B must be 2. A was 1, and this was minus a quarter. Okay, so this is a triangle, so know that this distance here is 1. Now I need this distance, so I'm going to sub in 1 into y to get the y coordinate of A. So I sub in 1, so I get 4, add 9, take away 30, take away 8. So A is minus 25. So this distance here is just 25. This is from 0. This is the x-axis, remember. So my triangle, that's labeled on, let's call this area 1, area 2. So area 2 is a half times 1 times 25, which is 25 over 2. And to get area 1, well, that's just the area underneath the curve between minus a quarter and 1. And we're just going to integrate what y is. So add 1 to the power, divide by the power, so it's x to the 4. Add 1 to the power, divide by the power, so it's me 3. 1 to the power divide, so it's me 15. And that just gives me 8x between minus a quarter and 1. Sub in the top number first. So 1 to the 4 plus, well, actually it's just 1 plus 3, take away 15, take away 8. Then sub in the quarter, the minus quarter, sorry, so minus quarter 4 plus 3 times minus a quarter. So 3, take away 15 times minus a quarter squared, take away 8 times minus a quarter. And then just sub in those numbers individually. So it's me 4, take away 15, take away 8. So this here gives me minus 19. And then this bit here, I'm going to take a while to type in. Let's cheat and use the answer button. So it's answer to power 4 plus 3 times answer to power 3 equal 15 times answer squared equal 8 times answer. And we get 261 over 256. I can see you guys asked for decimal now. So I'm going to work that out. So I'm going to do minus 19 minus that answer, which gives us minus 5125 over 256. Now, since it was underneath the x-axis, that's why it's a negative. So the area itself for 1, I can just ignore that minus. So it's just 5125 over 256. For the total area, we add them together, 25 over 2, add that. So do that on your calculator. And you get 8325 over 256. And that's a decimal, 2 decimal places, which is 32.52 2 decimal places. Okay, question 6. So we've got the curve C with the equation given there. So the first thing I'm going to do actually is I'm just going to write it down in a nicer form. So 2x, it's minus because it's on the bottom, it's a half into the square root. And the point A, which is 1, 5, lies on C. And C crosses the x-axis at B, which is B0, so we don't have that coordinate. And so it's verified that B equals 4. It's only 1 mark. So it's verified. So all we're going to do is by sub in 4 into there, I should get 0 because it lies on the x-axis. So it's a root. So if x equals 4, then 9, take away 2 times 4, take away 2 times 4, so minus a half. 9, take away 2 times 4, minus a half, it's 0. So therefore, b equals 4 as root. Yeah, and if you look, it's the only root that has. Then this is the tangent to C and A cuts the x-axis at the point D. Show that the equation of the tangent to C and A is y and x equals 6. Right, we like to show that question to know what we're aiming for. We're going to pretend we haven't seen the answer though, and it's mentioned tangent, so that means we gradient, so that means we differentiate. So dy by dx, ninth is minus 2x, which is minus 2, times by the power, so minus 2 times minus a half is 1, take away 1 from the power, so minus root 2. Sub in the x value, so at A, x was 1, well this is nice, so dy by dx equals minus 2 add 1, 1 to the power of anything is 1, so that just gives me minus 1, and it's tangent, so I leave it alone, so m is just minus 1, then use y minus y1, so let's just double check. A was 1, 5, so y was 5, equals m times x minus x1, 1. I'm going to expand by the minus 1 and take everything to this side, so I'm going to get x plus y. Actually, I'll bring the minus 5 to that side because I want the 6 on the other side. So there we go, x add y, which is the same as y at x, equals 6. Done. Then find the coordinates of the point D. Well, D was where this line crosses the x-axis. Remember, on the x-axis, we know that y equals 0, so that's the fact we know. Y equals 0, let's sub it into there, let's get x equals 6. So the coordinate is 6, 0. Easiest mark. And then, since the shaded region R is bounded by C, the line AD, and the x-axis. Use integration to find the area of R. Well, if we look, so here's A to D, and this is the curve A to B, it's there, something like that. And that's A, and the curve just like that. Well, and that's what we want, that's R. But to get that area, it's not an easy area to get. So what I'm going to do is I'm going to draw a line at the point X, that's what I know. And if you look on the outside, I can see a triangle. So to get this shaded bit, I can take away that white bit. Take away that white bit. And to get that white bit, I'm just going to integrate C between these two numbers, whatever A and B is. So let's just deal with the triangle first. So we know the coordinates of A was 1 and Y was 5. So this height here is 5. So it goes from 0 to 5. D, we just worked out, was 6. So from 1 to 6, it goes along by 5. So the area of the triangle is half times 5 times 5. So 25 over 2. And to get this dotted, get this dotted area here, I'm going to integrate the curve. So 9 take away 2x, take away 2x, and minus a half between, so A was 1 and B was, what was B again? B was 4. So I'm going to do that over here. So I get 9x, take away x squared, take away 4x to the half between 1 and 4. So sub in 4 first. So 9 times 4, take away 4 squared, take away 4 times 4 to the half. Take away the sub in 1, so 9, take away 1, take away 4. So 9 times 4, take away 16, take away 4 times 2. This gives me 12, and this gives me 8, 4. So this whole area was 8. So I get 25 over 2, take away 8. So the final area was 9 over 2. Yes, and look for the triangle and look for the bit we need to integrate. Find the numbers you need. So for the integration was a and b, the triangle was a and b. Subtract of this was d, and this was b. Okay, 4. Okay, question 7. Okay, this looks like an interesting one. We have y equals, I'm going to write it in a nice form, so a quarter x squared plus 2x minus 1 plus 1, and a tangent and a normal to the curve drawn at the point x equals 2. Okay, and we want to find the area bounded by the tangent, normal, and the x-axis. Okay, so this definitely sounds like a job for our graph. So let's draw that first of all. So it was x squared over 4 plus 2 over x plus 1. Zoom out. So we've got a graph that looks something like this. 2 was about here. So our tangent is going to be something like this. And the normal's going to be something like this. And we want the area bounded by the tangent, the normal, and the x-axis. So we want this here. So what we need is the height of the triangle. So the height of the triangle would be the y coordinate here. Then we need the length of the triangle. So we need these two x values here. So we need the intersections. So let's do this bit by bit. So first of all, let's get the y coordinate. So when x is 2, we sub it in into there. So we get 4, well, we can do that head can't we? 4 over 4 is 1, 2 over 2 is 1, so y is 3. Then we need the tangent and normal, so we definitely differentiate it. So dy by dx gives us a half x minus 2x minus 2. We sub in x is 2, so we get dy by dx equals, well, that gives us, let's doing a calculator, so I'm making things stupid. 2 times 2, 7 minus 2. So I get dy by dx is a half. So the gradient of the tangent is a half, and the gradient of the normal is minus 2. So let's get the gradient, let's work out the equation of the tangent. So y minus y1, so y minus 3 equals a half x minus 2 times by 2, so 2y take away 6 equals x take away 2. Take everything to one side, so x minus 2y plus 4 equals 0. That's the tangent. Okay, now here was the tangent. So to get this point here, where it crosses the x-axis, is when y equals 0. So let's set that in. Get x plus 4 equals 0. So x equals minus 4. So I've drawn my tangent completely wrong. It should have been more like that. So x is minus 4, so that's good. Then do the same thing for the normal. So y minus y1, so y minus 3. So look, it looks the same. The only difference for the normal is that the gradient was minus 2. X minus 2. Expand that. Y minus 3 equals minus 2x plus 4. Take it to one side. It's 2x plus y minus 7. So that's what the normal was. And again, to get this point, I'm going to sub in y equals 0. So I get 2x minus 7, 0. So x is 7 over 2. So let's look at this triangle in a bit more detail. Big picture. So I knew this point was minus 4. And this point 7 over 2. This point, well, I don't need the x coordinate. I don't care where it was. I just want the height, which was y was 3. So I need the distance along the bottom. So from minus 4 to 7 over 2. So I just add them together, I get 15 over 2. So 7 over 2, add 4, sorry. Add those together, so I get 15 over 2. So the area is just a half times 15 over 2 times 3, which gives me 45 over 4. Yeah, it was a tricky question. I remember that was one of the last questions on an OCR paper. So very tricky, but lots of chances for you to show your knowledge. Lots of chances to pick up marks by working up gradients, differentiating, tangents, normals, and possibly even having to go and working this out. So there's no integration needed for this. And I guess you could spot it because, well, it was an AS paper, or you didn't know that. And on AS, you don't need to know how to integrate x to the minus 1. Okay, I'm going to pause the final time, ready to do question 8. I'm going to take a picture. Okay, and last one, question 8. We have that curve there, y equals 5 minus x, x minus 1. And it says, diagram shows part of the curve and the line x equals a. Given that the total area of the regions in the diagram is 19, determine the exact value of a. Well, I'm going to draw the sketch, so I have to keep that there. So that's just the sketch of the curve. Well, if the equation was 5 minus x, x minus 1, that means the roots are 5 and 1. So that must be 1, that must be 5. And then a is here somewhere. And we know that these two areas added together gives us 19. So we're going to have to integrate. So let's expand that bracket first. So y equals, let's do some quick expanding, 5x, take away 5, minus x squared, plus x, so y equals 6x, minus 5, minus x squared. Okay, so we've got what y is expanded, so it's ready to integrate now. So if I integrate it between 1 and 5, I should get this answer here. This area, 6x minus 5 minus x squared. So we get 1 divides 3x squared, take away 5x, take away a third x cubed from 1 and 5, sub in 5. And sub in 1. So 3, take away 5, take away a third. Yeah, then sometimes I like to give you a nice number. So if I sub in 1, look, you can just ignore the x's. So if I sub in 5, and it's really important you do these two bits separately. Take away 25, take away a third, 125. So this number here was 25 over 3, and this number here is going to be 7 over 3. So altogether, it gives me 25 over 3 minus answer 32 over 2. So that's this area here. Let's label that A. So that's the area for A. For B, we would do the same thing, but between 5 and A. So integration between 5 and A, the same thing. That's a good 9 to make that more than A. So it's going to give me the same thing. 5 and A. This time we sub in A first. I get 3A squared. Take away 5A. Take away 1/3 A cubed. Then I'm going to sub in 5, which, if I look over here, that was where the 25 over 3 came from. And now this should give me this negative bit there. So what we're going to do, so that's the area B. So I'm going to times this by minus 1 to turn it into a positive. So B is 25 over 3. Take away 3A squared, take away 5A, take away a third A cubed. And we know that A add B is 19. So we know that 33 over 3, add all this. Should equal 19. Well, let's see what happens when we do that. So let's just make sure you're happy with y times this by minus 1. So sorry, this bit, give me the area here. So it should be negative. So I want that as a positive. I can't even see it. That give me that area there. I want that as a positive, so I times by -1 to change the negative into a positive. So this is the positive area. So I add it with air, and that gives me 19. If I didn't times by -1, and I just added this with air, then what it would give me air, take away this. Because remember, negative area would take away from the positive area. Okay, I'm hoping this is going to give me 19. I'm going to work that out. 32 plus 25 divided by 3 gives me 19. Good. So this thing here simplifies to 19. And I'm still going to just leave that in the bracket. So that I can take away 19 from both sides, look. So that gives me 0. And I can just times both sides by -1 to get 3a squared, take away 5a, take away third a cubed equals 0. I can times by doesn't matter, let's times by 3 to get rid of the third. So 9a squared, take away 15a, take away a cubed equals 0. I can factorize out an a, so 9a, take away 15, take away x squared equals 0. And then I can sort, well, I'm going to rewrite this first of all as -a squared plus 9a minus 15, so you can see where we're going with this. This thing here gives me a0. This thing here is just a quadratic, so I can type that in my calculator, and we get -1, 9, minus 15. We get two answers. We get a equals 9 plus or minus √21 over 2. Now, looking at the picture, we know that a has to be bigger than 5. So if you look at my two answers in my calculator, the -1 gives me 2.2, positive 1 gives me 6.7, so it must be the positive one. So therefore, a equals 6.7912, or as an exact answer, 9 plus √21 all over 2. That's because a is definitely bigger than 5. Now that one's a really tricky one, and again, it came at the end of the paper. So see how far you could have got yourself.